In this video, we'll continue our discussion of work integrals by working another example. Find the work done by moving along the line segment, so we have 2 points there. We need to define x of t, y of t, and z of t. So we want that line segment. We want to find the work done through the vector field from that point to that point through the vector field given. This is a line segment, so I treat it the same way with growth. Okay, it goes up by 2, so it's 2t minus 1, because it's where it started is minus 1. If I look at y, it's 3 down to negative 2. That's a negative 5 growth. And then I put plus 3 because that's where it started. And then the last thing is 2 up to 4. That's a 2t, but it started at 2. Anytime I do this, the t's are defined 0 to 1. The way that that's defined. All right, if I'm using my definition, I have it right there faintly in left up there. I need to find r prime, which we just came up with. 2t minus 1. Negative 5t plus 3, and 2t plus 2. And using the definition, I don't need the magnitude, but I need the derivative. Thankfully, with all these linear functions, they turn out to be nice and pretty. I also need to put f, which is right there, in terms of our definition. I'm going to scoot this over because I'm going to run out of room. So I need to do f of 2t plus minus 1, comma, negative 5t plus 3, comma, 2t plus 2. Okay, and then I got to plug that into the vector itself. All right, x plus 2y, I like to do these off to the side, plus 2 times negative 5 plus 3. It's just much easier. 2t minus 1 minus 10, that's a t, minus 10t plus 6. So the first thing we're going to get is negative 8t plus 5. That is changing f in terms of t. Okay, we also want to do 2z. That's a little easier. We got 4t plus 4. That's 2z. And then we got to do x minus y. All right, that's 2t minus 1 minus y is negative 5t plus 3. That's going to be 2t minus 1 plus 5t minus 3. We got 7t minus 4. Okay. That redefines that for me, all in terms of t. It's going to make my life easier that I did it that way. And now I just got to find my dot product, dotted with r prime. Okay, that's going to be 2 times negative 8t plus 5 minus 5 times 4t plus 4 plus 2 times 7t minus 4. It's a dot product. This is going to give me a negative 16t plus 10 minus 20t minus 20 plus 14t minus 8. All that's going to work out to be, let me pull that up here, negative 22. Negative 22 minus 18. That is what goes in our integrand. We know t is from 0 to 1 from above. And then I have that dot product, dt. Nice and easy. We integrate. I get negative 11t squared. Check your derivative going backwards and you can see that it works out. 18t. And then 0 to 1. Thankfully, though, the 0 is just going to cancel things out. I got a negative 11 minus 18, giving me a negative 29. So that is the answer to that line integral from that point to that point along the line segment. This is a neat method. Really, it kills all the difficult calculus with the dot product. I think the most annoying part about this method is this kind of thing. I find myself the better if I slow down and try to not skip steps and write all that out, I'm less miserable as I go through these problems. When I'm sitting and looking at my notes, I try to skip steps because my notes are just for me. And I'm looking through my notes and I'm like, it's kind of hard to keep a hold of things, but when I write it out like this and just do it off to the side, it makes it so much easier. It's easier to find my mistake if I mess up, stuff like that. So get some practice.